All right, so you asked me this question, and I was busy in the past 3 days, so I was only able to let you know write down everything and make a video for you. So anyway, this one I CH2 CHI CH2 CH2 CH3. This is what the question wants. All right, you have the pentane and you have iodine in that pentane. So write down the compound carefully. So this is the reaction you want. Okay. And this is the compound that you are going to use, which is pentane, CH3, CH2, 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 CH3. So you have 5 carbon here. Count the carbon number in the compound that you want as well. The question say that ICH2, CHI, CH2, CH2, CH3. So you had 1, 2, 3, 4, 5. So altogether you have 5 carbon. So the compound that you're going to use is also 5 carbon. And the chlorine, sorry, not the chlorine, the halogen that you're going to use is iodine, not chlorine. All right, so if it say chlorine, you will have to write down chlorine. If it say bromine, you will have to write down bromine, but now it is iodine. So the initiation is always start with the halogen. I2, you put it into HV, so that means you expose the I2 to HV, you got 2 radical. You got it by like this. I2 is like this, right? 2 iodine connected with the covalent bond, and HV will break this bond. And what happened is that each iodine element will get 1 electron, and you got 1 electron for each iodine, and you call this radical, iodine radical. And because you have 2 iodine radical, you put 2 and I and radical. Okay, so that's the initiation stat. And another one is propagation. You're going to start using this one, which is pentane. You have 5 carbons here, and you're going to react this with one of the iodine radical. So what happened is that you're going to use at the first carbon. So the hydrogen atom that is attached to the first carbon will go to this iodine radical. So what happens to this first carbon is that it lose 1 hydrogen. So it will, how do I say, it will lose, like, electron that is sharing with the hydrogen, and you will have the free radical for the first carbon. Okay, oh my god, I didn't write this down. CH2, and then the rest stay the same. CH2, 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 CH3. So the rest stay the same. Only the first carbon becomes the free radical, and because this I radical get hydrogen from the first carbon, it becomes Hi. So now you got the radical, and you don't want the radical, so you will have to react it with the iodine again. You got the iodine because the question gives to you, and you can use as much iodine as possible as long as you get the final results. So you copy this one in this stat, and then you react it with I2. So one of the iodine will go to this compound. Okay, so this electron will share with the iodine, so you begin like this. ICH2, I go to this one, ICH2, CH2, 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 CH3. So all this while the carbon number does not change. All right, you're just playing with the free radical, and you're just playing with the electron. So you got this, and because iodine lose the sharing on electron, it becomes free radical. Okay, so now you look at the compound and you compare it with the compound that you want. Now you got the ICH2, but the second compound is actually, the second carbon is actually CHI, but this compound that you have is still CH2. You don't have I yet, so you will have to continue your reaction. So you write this compound in the next step, and you react it again with the free iodine, iodine free radical. Okay, so this time in the beginning you break down the first carbon, right? You break down the first carbon, but in this step, because you have already broken down the first carbon, you have to break down the second carbon. That is why the result is that this second carbon will become free radical and lose 1 hydrogen electron. Look at this second carbon, it is H2 in the beginning, but after it react with the iodine free radical, it becomes free radical itself, it lose 1 hydrogen, and this hydrogen go to this iodine radical, so it becomes HR, iodine radical to HI. This iodine get H from carbon number 2. Okay, so again, you don't want the free radical, so you will have to react this with iodine again. So here you write the compound again, and then you react it with I2. So as I have mentioned, this I, it has 2 iodine, and this one of the I will react with this second carbon, and the free radical will disappear. So it will become like this: ICH2 CHI. So I is attached to the second carbon right now. The rest stay the same, but because this iodine lose the sharing electron, it becomes free radicals. And now you got the compound that you want. This is the compound that you want. You compare it, this compound with the compound that you want, and now you got it exactly that. Okay, so you start the reaction now. So you will have to terminate everything. So what do you do in the termination step? You react all the radicals. First, iodine radical, you react it all together and it became I2. And then this radical, you react it, the first carbon radical, and then you react it and it will become a very long one. Okay, because I don't have enough space, I'm not going to write it down. And this one as well, you just write it down. Okay, you just read it. So I hope you understand this. Everything is actually playing with the radical, breaking down the carbon, and you get the radical. Okay.